I'm going to try to use the limit laws to evaluate a pair of limits. And here is a function that is the quotient of an exponential function and a polynomial. I would very much like to use the quotient limit law in order to evaluate this limit. And I know that exponential functions and polynomials are nice, friendly functions that are continuous on their entire domains, and this is fantastic. But here's the problem. The limit as x approaches 3 of the bottom function, x squared minus 9, is equal to 0. So although both limits exist, the denominator limit is equal to 0, and this means I'm not allowed to use the limit laws to compute this limit. So now I need to pivot from proving that the limit does exist to proving that the limit does not exist. My preferred method is to use a table of values to show that the y values get all crazy, and therefore the limit can't exist. So in fact, using a calculator, here's a table of values for several numbers that are approaching 3 from both sides. And you can see that as x approaches 3 from the right, that means that the x values are higher than 3, that means that the y values are getting arbitrarily high, really huge, really positive. But as x approaches 3 from the left, meaning that the x values are just a little bit less than 3, then the y values are getting really, really low, really large, really negative. And this means that this limit does not exist. Here's a second example, the limit as x approaches 4 of x minus 4 over ln x. Again, these are two functions that are continuous on their domains. It's a quotient of two happy, friendly functions. And in this case, I know that the limit as x approaches 4 of just the numerator function is 0, and the limit of the denominator function as x approaches 4 is ln 4. Not an integer, I don't care. But here's the thing. They both exist, and the denominator limit is not equal to 0. And that's great. That means that the limit law actually applies here, and I can say that the limit as x approaches 4 is 0 divided by ln of 4, or just 0.